Hello and welcome back. In example 1, we're given a set of parametric equations, x equals a cosine t and y equals a sine t. A here is some constant. And t, the parameter, is going from 0 to 2 pi. So that's the parameter interval that we're considering here. It says first eliminate the parameter to find a Cartesian equation of the curve, and then describe the graph. Now eliminating the parameter t here is a little bit trickier than that other example that we did. We could try to solve for a t, one of these equations for t, but then you'll get like an inverse sine function, and then you've got to figure out what cosine of inverse sine might be. Let's look at an easier way to handle eliminating the parameter of t here. There's an equation that you know that relates sine and cosine together in this equation, and that's the Pythagorean identity. Sine squared t plus cosine squared t equals 1. We're going to use that Pythagorean identity to help eliminate the parameter of t here. So first, let's take each of these equations and solve them for cosine t for the first equation, and we get cosine t equals x over a. And then sine t for the second equation. Sine t is y over a. I'm going to write the Pythagorean identity as cosine squared t plus sine squared t equals 1, just to put the x's up in front in a moment. It's the same thing. And now remember, cosine squared t just means cosine of t quantity squared. So we can write, instead of cosine t, we can write x over a, and then we have squared, plus, then instead of sine squared t, we're going to write y over a quantity squared equals 1. Now the square applies to the top and the bottom, and in fact you can, we'll do that. So we have x squared over a squared plus y squared over a squared equals 1. We can multiply both sides through by a squared, and we get x squared plus y squared equals a squared. There's your Cartesian equation. That's an equation that's only in terms of x and y. There's a constant a in there, but that's just a constant. That's okay. So there's the Cartesian equation that is going to represent the path that the parametric equations are going to travel on. Now it says graph and describe this graph. Well, if we draw a little coordinate system in the xy plane, then the graph of this function, or of this curve, looks like a circle with radius a. So we can write our scale with a's in it. I'm going to draw in light gray a very bad circle. So there's a circle with radius a centered at the origin. Now our parameter interval, it says, is t goes from 0 to pi over 2. So that's going to be a clue that we're going to go all the way around this circle, right? But let's just confirm that. So when t equals 0, we have cosine of 0 is 1, and then times a is a, so x is a, and then you'll get sine of 0 is 0, so y is 0. So right here will be the t equals 0 point. Then as you increase your t, like let's say to pi over 2, then cosine pi over 2 will be 0, so x will be 0 in that case, and sine pi over 2 will be 1, so you'll get y equals a. So here's the t equals pi over 2 point. Then t equals pi will be on the left side of the circle, t equals 3 pi over 2 will be on the bottom, and then t equals 2 pi will be all the way around the circle. So it seems like we're traveling counterclockwise around the circle once. Trace my bad circle. I'm going to put some arrows that indicate the direction that we're traveling. We're traveling counterclockwise. So it says describe the graph. Well, it begins at a comma 0, and it traverses like it walks along the circle centered at the origin with radius a. Once. Goes around once. Going counterclockwise. There. So we've graphed it, and we've described exactly what that graph is doing, and not only that, but we've described the direction that the particle is moving as it goes along that graph. In the previous example, so this example 1, what would happen if we let our parameter interval be 0 to 4 pi instead? What do you think would happen? So if you said that we would traverse the circle twice, then that's correct. The circle would be traversed twice. If it were 0 to 6 pi, 3 times, and so on. If it were 0 to just pi, we would only go halfway around the circle. Still going counterclockwise, though. Now, one other note before we close off this video is that any function y equals f of x, so that's a Cartesian equation, right? That's a Cartesian equation, but written using solved for y. Any kind of function y equals f of x can be parameterized by letting x equal t and y equal f of t. That would be a set of parametric equations that can handle any function of x. So for example, the parabola y equals x squared can be parameterized by what? What do you think that would be? You said x equals t and y equals t squared, then that would be correct. Because then if you went back and you eliminated the parameter t, all you would do is replace the t over here in the second equation with x. So if you always let x equal t in those cases, then y can just be the original function, but with t's in their place. Thank you for watching this video, and see you in the next one.